of questions won't be there. I mean, for graph theory, you can assume the same level of questions or little less maybe. But for calculus, obviously, these kind of question won't be there. So I'll just, yesterday we solved question number 1, 2, and 3, right? It was based on parabola. So that type of question you can assume because that is not that much difficult, right? You just have to observe that the particular parabola is upward, downward parabola and all those things. So first, second, and third, these type of questions could be there in the final exam.
Ma'am,
and this, yeah.
Like in previous session, you said that there would be 75% weightage from this graph theory, but in the mock it is not there. So, like what kind of weightage we can expect from graph theory?
I told you the weightage. I mean, from 9 to 12, you can assume 75% of weightage, right?
Okay.
So
But this
from
weightage is
graph
not
theory, you
there
can
in...
assume, yeah, it's not there in mock, right?
Yes, ma'am.
That's your concern, no? Yeah, this is actually, it's not a exact mock, you can say, of our end-term exam. I mean, we won't follow this particular pattern, whatever the mock is following here. So that's why I'm telling you that 1, 2, 3, this type of question could be there. But again, since here we just contain 2 or I think 2 questions are there from graph theory, right? In the mock.
Yes, ma'am.
But in the end term, you will see at least 4 to 5 questions from graph
From
theory.
graph theory.
Yeah.
And ma'am, from calculus?
Calculus will be the rest of the thing. I mean, you can consider again 1 and 2 from limit, continuity, differentiability, 1 and 2 from integration. So, such kind of thing you can consider. Week 9 deals with integration, right?
Yes, ma'am. Integration. Definite integration.
So, definite integration.
Yes, ma'am.
Okay.
Ma'am?
Yes. Anything else?
Yes, ma'am. Hello. Ma'am, you think the first, second, and the third question? Can you show that if it's on? I couldn't see. I think I joined the.
You haven't joined yesterday's session?
No. I joined yesterday's session. I was there for the entire thing. So you saying 1, 2, and 3? These will you circle it on the left top, right? Left top corner.
Okay. You are not able to see my screen. Is that the thing?
No, I can see your screen. I just want to know which what are those questions? Question number 1, 2, and 3 that you circled on the left.
Okay. So these are that parabola question. There is one pole of length 15 meter, and some ball is thrown from here, and some fire.
Okay. So you're talking about the questions that we discussed yesterday, na?
That particular first question.
Okay, got it.
So that type of question can be there. The question number 4, I mean, this type of question also you can consider for your end terms. Because here what is happening, you just have to judge the graph that which function will be the best fit of this particular graph. So here I just solved this question. So here what first thing we have to consider is this inside parabola, right? So this is a parabola. So every expression here, which is inside the bracket, actually represents a parabola. Yeah, I'll show the whole solution. Okay, so here what happened, every expression inside this bracket actually represents a parabola. So if you find out the roots of this parabola, so there will be 2 distinct roots. There will be 2. Distinct or same, you can check via the root, right? Distinct roots. So here I consider the first expression, x square minus 14x minus 45 is equals to 0. So if you take minus common and factor it out, you will get 2 roots, namely minus 9 and minus 4, right? And similarly, if you take the second expression and find out the roots, they will be 9 and 5. So here I just want to draw this particular parabola with the logarithmic function. What will happen? So if you consider this particular parabola, so then what happened? It's actually a downward parabola with 2 negative roots, minus 9 and minus 4. So if you try to draw that particular parabola, these 2 will be your axes, and these 2 will be the roots, minus 9 and minus 4. But since what happened, when log function is there, and we know log will take what you can say, tangential behavior when the expression becomes 0, right? The inside expression becomes 0. So same thing is happening here. So this expression, this minus x square minus 14x minus 45 will become 0 at the points minus 9 and minus 1. So that's why these two tangents are there. Tangents, or what you can say, we have two type of line, tangents and asymptotes. Yeah, right. So these two will be the asymptotes of this particular asymptotic behavior will be. Okay, so that's why. And one thing is, in the first option, one minus sign is there. So it's a downward parabola, but if you take minus sign, it will become an upward parabola with the same two asymptotes. So that's why the best fit for this graph is nothing but the first option. Is that fine? Any doubt in this question?
Ma'am,
You
yeah,
just have to draw the graph.
I think there's a question in the chat also, which says that how do we figure out which equation will fit the best?
How do we, that's what I'm saying now. First thing
No,
is
they
you
are
observe
asking
what are
about
the
the-
parabolas.
They are asking about the graph, like how do we figure out how the graph will look like? That's the question in the chat box.
Yes, ma'am. This is a problematic question.
Yes, ma'am.
I mean, how could you figure out? See, this parabola graph, you know how you can draw the parabola graph. Simply log function actually giving you what are the asymptotical behavior will be there. So this parabola graph, so minus x square minus 14x minus 45. This paragraph, parabola's graph you can easily derive, right? So what will be the graph of this parabola?
This upward, downward.
Ma'am, it should be downward parabola.
Correct. So it's just a downward parabola with two particular zeros, and the zeros are minus 9 and minus 5. So you just draw a downward parabola, right? This thing is fine. Now you just applying the log function. So what is the characteristic of log function? That if the expression becomes 0, there you have asymptotic behavior. So because of this log function, you are getting these two lines, or minus 9 and minus 5. And now you are multiplying with minus sign. So it just invert itself. Yeah.
Ma'am, this log function gives the asymptotes.
This log function will give you, see, log function, this is a graph of log when base is 10. So that means whenever our x value reaches to 0, our log function actually reaches toward minus infinity. But here minus sign is there, so it will reach to plus infinity. And since we have two values where our function is becoming 0, minus 9 and minus 5, that's why such kind of behavior is happening.
Oh, okay, ma'am. Now got it.
Okay. So that's how you will draw a graph. Start with the initial thing, whatever you know, and consider all functions which are applied. Yes.
So is it that we figure out how the log function or the graph looks like by using Desmos, and then like we apply?
No, you can't use Desmos in entire exam, right?
Yeah, we can't. Yeah, no, not using it. I'm just saying. So we learn how the graph looks like at home, and then once we reach the exam hall, we can learn from what we've understood by using Desmos from home when revising.
You don't need to learn it. This is what we have done in previous weeks, right? How we were drawing the graph.
I mean, how could you draw the graph? Start with the initial function, then apply the next one, and then apply the next one. That's the rule, right? This graph, you know. Now, if you apply the log, what will happen? If you apply the minus sign, what will happen? That's the basic rule of drawing an equation, right? Same thing we draw with the modulus also. So if you have any function and you want to find out the graph of its mod, what you will do? Just reflect all things which are in toward the negative axis into the positive axis. If this is a graph, the below one is the graph of f of x, then this above one will be the graph of mod of f of x. So such kind of restriction, I think you guys are already know. I mean, if you apply a function, what are the things are going to change? That's all you have to observe. That's it.
Ma'am, that log application, what it will show, how it will change?
So it won't change the total figure of your parabola. It will just say that it will have 2 points, minus 9 and minus 5, where the function is observing an asymptotical behavior. So these two lines will become asymptotical. That's all.
Okay, thank you.
So some kind of thing you can say that log is bounding our function to lie in this particular strip.
Restricting the function.
Restricting the function.
Okay,
is that fine? Yeah.
Ma'am, so in this case, the answer would be the third option.
The first one.
Option
Why should answer it be third?
No.
Here the roots are in negative, na? So
Can you explain minus sign effect in
See,
first
if you
option?
multiply by a graph with a minus sign, what happen? All the values which are positive will become negative, right? And all the
Yes.
values which are negative will become positive. So we are doing the same thing. So here, if you multiply by a minus sign, so if you multiply, since suppose this is your graph of a parabola, and if you multiply with the minus sign, what will become? That whatever positive values are there, they will become negative, right?
Yes.
So that means your parabola just got 180-degree angle shifted or rotated 180 degrees. That's it.
Okay, ma'am. Understood. Means the parabola is upside, downside. Because of minus, it will go upside.
It will go upside.
Okay.
Ma'am, it's only function value will change, but that the roots will be remain same even if it is upwards or downwards.
Roots, what do you mean? I mean, the roots of this polynomial is -9, -5. The roots of this polynomials are 9 and 5. So they have a little difference. So these are positive roots. So if you want to draw the graph of this particular function, minus or log of, then it will become here. The same graph shifted toward the positives. So that's the difference. That's why the second option is one.
It means that if the logarithmic function appears, that the negative sign will be reversed as a positive or positive will be negative. Like that we can take, because roots will not be changed. -9,
Yeah,
9
roots
and
won't
5
change.
is the
Obviously,
roots,
roots
right?
won't change.
I
Yeah,
thought it will
roots
be in
won't
the
change.
plus quadrant, like that in the right hand side.
No. Minus is,
But
I mean,
but
minus sign can't be go inside the logarithmic function. It will stay outside only.
okay.
Ma'am,
Mm.
ma'am, in the
It's a
third
little bit
option,
confusing, ma'am.
ma'am,
Yeah.
ma'am, in the third
Yes.
option, as you said that the roots will be negative.
Hmm.
So that's, I mean, so we can conclude that the graph should be on the right side of the y-axis for the third option, ma'am.
For the third option, yeah. So the roots will be
Negative.
9 and 5.
Ma'am, it would be
minus 9 and -5.
Yes, ma'am. So the graph should be on the right side of y-axis.
Yeah, but it will be a downward parabola. It won't be an upward parabola because this is an upward parabola. This inside expression is an upward parabola, right?
Yes, ma'am.
It's an upward parabola with sorry, this won't be here. This is your y-axis.
Okay, and
With
then if you log on it, it will invert.
Yeah. So minus sign will invert it. So it will
Ma'am,
become
but
a
the
downward.
same thing is going to happen in the first one also, no, ma'am?
No, it's a downward parabola. Now, first one, initially, it's a downward parabola. Initially, it's a
yes,
downward
ma'am. Yes,
parabola.
ma'am. Sorry, ma'am. Sorry. Got your point, ma'am. Thank you, ma'am.
Fine.
Yeah, ma'am.
Okay.
I
So let's
didn't
move on.
understand how log is affecting the line of the equation. Can you please explain?
Log is actually not affecting, I mean, log won't give us any different value. I mean, it either shrink your graph or expand your graph. Here, what is happening? Log function is actually giving us these two asymptotes. These two dot line is there now. This is because of log. That's all.
Okay.
While log won't change your shape of graph. I mean, either the graph can stretch down, or you can say either the graph will be zoom out or zoom in type of thing could happen if you apply the log function, and it will suggest some asymptotic behavior where the function is becoming zero. So here what happening, the zeros of this parabola is -9 and -5. So that's why at -9 and -5 we are seeing some kind of asymptotic behavior. That's why this graph lies toward the left hand side of your y-axis. Otherwise we can't judge, right, how it is lying toward the left hand side.
Okay, and what about the negative sign which is outside the log, ma'am?
I explained 3 times about this negative sign. What happened? If the negative sign is there, then obviously your graph will change 180 degree, correct? All positive things will become negative. All positive values of x will become negative. Is that fine?
Yeah.
Is the fourth one is the inverse of the first one, right? Fourth equation
You
is
can
the...
check. I'm not sure about that. You
Ma'am,
can check by F composite.
Ma'am, what did you comment for this option C, ma'am?
I says that for option C, it's initially an upward parabola, right?
Correct.
If you
Okay.
apply the log,
Mhm.
here's the, and if you apply the log, it will become asymptotic. And since the minus sign is there, it will become inverted and it will become a downward parabola. So that's the thing happening in the option number 3.
So how is that different from option D, this graph?
It's an upward parabola, it's in downward parabola. So
No,
how could you,
option D. I'm talking about option D.
It
you are
will
talking about option
downward.
number B?
It is
It is option 4. It is a downward parabola.
yeah, correct.
Okay,
So
so
how?
you want,
In
Can you
but
please
but
explain again?
in first option,
That
it is
minus
downward
cancel,
parabola.
no?
Yeah,
I'm
because
not
of
talking about
minus.
this option. Listen. I'm not talking about option A and option D. I'm talking
Yeah.
about option C and option D.
Okay.
option
According to
number
ma'am,
C and option D. Okay,
yes,
so option number C actually. Option number C and option number D you want.
yes, ma'am. According
What's
to
the
you, ma'am,
difference
this
between option number D and option number A? Only
no,
minus sign is different,
yes,
no?
minus.
So
Yes.
yeah,
According
so
to you,
it
ma'am,
will,
this both
But
will
that
give the
minus
same
sign
graph.
will cancel out, right?
I think roots will be different of C and D.
No.
C. Yeah, roots will be different. This roots are positive 9 and positive 5.
It will
Here
also
it
be
will be
positive.
minus 9, minus 5.
How can you say that?
Ma'am, in both the case, it will be negative, ma'am, not positive, ma'am.
What?
Yeah, the roots will
I
change.
mean, root will be
Yeah,
negative
ma'am.
in both
This,
the cases.
okay, sorry.
The
This
roots will
has
be
9, 5. This has minus 9, minus 5. And this also has minus 9.
Yeah, roots will be same. You said both will have same this graph. How is that possible? Log of minus
I know
x.
there is actually a
Both
difference.
can't
We
have
can
the
say
same.
that.
This is an initially. Okay, wait a second. Now I'll mute everyone. I'll draw the 4 graphs and then you will tell how it's the same. Okay. So this is the graph of first one. So here, initially it's a downward parabola. So it's a downward parabola and the log we have asymptotic behavior. And then because of the minus sign, it will become an upward parabola with these two asymptotes. Okay. Now the second option is here we have roots plus 9 and plus 5. Right? Minus of x square, plus 9 and plus 5. So, and initially it's also a downward parabola. So initial its graph will something like this. Because of log we have to asymptotic behavior. At the end its graph look like this. And the third option here it's an upward parabola initially with the roots minus 9 minus 5. And if you apply the log it will become upward parabola with the asymptotic behavior. But because of the minus sign it will become a downward parabola with the asymptotic behavior. Okay. Now the fourth one. So the fourth one actually having the negative roots, namely to be minus 9 and minus 5, right? And initially it's a downward parabola. So this fourth one is here. So it's a downward parabola with these two roots, minus 9 and minus 5. And if you apply the log, this will become your graph. So in these two kind of having the same graph, but there will be a little change. Yeah, these two expression kind of will have same graph. So someone was saying that, right? Yeah, now you can mute.
In option D, there's like
they both cannot
no
have same
negative
graph.
sign.
Ma'am, in option 3, I think the graph would be on the right side, ma'am.
Ma'am,
Actually,
Yes.
This
That's
is
the
minus 9 or minus
we take
5
minus
plus 9.
common from option D so that C and D will become the same equation?
I'm not sure about this.
Log is not defined on negative value.
Ma'am, if you use
check about that
Desmos,
constant
it will
also.
be.
Ma'am,
If you use the Desmos,
Okay,
it will be
see,
good.
it's not. I'm just
Minus
see,
45
in
and
exam
plus
you can't use the
45
dash.
shifts the graph to right and left. That's the difference.
Yeah,
Yes.
see, this is having the roots 9 and 5, right? I think mistakenly because 9 and 5 will become
minus 9 and minus 5. Roots are still minus 9 and minus 5.
Minus 9 and minus 5.
Minus 5. And this expression will come out to be minus of x minus 9, x minus 5. Right? Plus 9 plus 1. But here the domain will be restricted. I mean, there will be some change because the log is not defined over the negative thing. So,
Ma'am, am I audible?
Yes, yes.
Ma'am, the roots are different. I just checked on Desmos. Both the roots are different for C and D.
So what's the roots of the C option?
So C option, it is 1 second.
9 and
Minus
5.
9 and minus 5 should be there, right?
No, 9 and 5.
Roots.
Hey, 9 and 5 will be there now. Yeah, confused. Here also 9 and 5 will be there.
It can be minus 9 and minus 5.
Ma'am, third will be -9 and -5, ma'am. If you
Yes, yes.
if you
Because of the
No.
minus log sign, actually it is changing.
हाँ, मैं पहले से ही लिखा.
No.
Wait, it's x square plus 14x plus 45 is equals to 0. So it will become x plus 9, x plus 5 is equals to 0. So that means minus 9 and minus 5
Yes,
will be the
ma'am.
roots. Same thing
Yes,
for
sir.
here also, minus of x square plus 14x plus 45 is equals to 0 will become x is equals to minus 9 and minus 5. So what's the difference here? It will be the same parabola,
Yeah,
just
it
the
is- it is.
direction is changed. It will be the one will be the upward parabola, another one will be the downward parabola. That's all. And since we are applying the log and minus sign, so here we are applying the minus sign, so that's why it will change to the, I mean, it's initially it's an upward parabola, it will change to the downward parabola, but here there is no minus sign, so that's why it will still remain a downward parabola. So that's why the graph of both things
Ma'am, it is
will
not
be
exact.
similar. Exact won't
ma'am,
be there, but yeah, the
a parabola.
whatever figure will be there, that will be same.
Ma'am, could you just
Fourth
use
one,
Desmos
can you
once? Ma'am, could you just use Desmos so everybody gets a clear idea, no? Like we are trying to.
For that, I have to leave this window. Okay, I mean, you can easily plot the graph now. I have given you plenty of the information that how you should figure out what will be the graph. Is that fine?
Yes, ma'am.
So let's
Just a
move to
minute,
the
ma'am.
next
Just a
question.
minute.
Yes.
That fourth one, minus x minus 9 and x minus 5. Before that, there will be a minus, right? So,
So that won't affect. Minus sign will just tell us that it's a upward parabola or downward parabola. That's
And basically the domain of log should be like greater than 0. That's why we equate it to greater than 0 thing. And then there will be changes.
yeah, I mean, you don't have to worry about domain right now that much. Just a rough idea for this question will be enough. Right.
The question, my doubt actually in this was, ma'am, option 3 graph is behaving differently, ma'am. That's why, ma'am, we will discuss in last. We already spent a lot of time on this question.
Yes, ma'am, please.
Because yeah, I have to complete this session up to till 15. That's all I can give you time. That's why I'm just rushing. Okay. So any doubt in question number 5?
No, ma'am.
Everyone is okay with this question. You
Ma'am,
just have
can you
to expand.
Ma'am, excuse me, can you say why the option D is correct? Why A and F are empty? I have stuck with that only, ma'am.
In this particular question.
Yes,
Question number
ma'am. Yes,
5 or
ma'am.
question number 4?
Question number 5, ma'am. I'm asking about the option D. Why why the A and F are empty? Below, ma'am. E.
Okay,
A
okay.
and F are empty.
Okay, why A and F are empty you want to ask? See, what is
Yes, ma'am.
A?
That is
So,
the correct option.
okay, so A is empty because of the thing that what is A? So A is nothing but X minus Y union of Z. So here first thing you have to observe that what is X? So X actually contains all the natural number which are divisible by 100. And what is Y? Y will contain all the natural number which are divisible by 25. Now, if you observe, if a number n is divisible by 100, then it is automatically divisible by 25 because 100 is nothing but 25 multiplied by 4, right? So if a number is divisible by 100, then it's automatically divisible by 20. So that means whatever number present in the X also present in Y. And here for constructing A, what we are doing, we are excluding Y from X. Ultimately, we are excluding this particular Y set from the set X. So that means we are excluding the whole set. So that's why A is equals to empty. Because of the simple reason that if a number is divisible by 100, it will be divisible by 20. Is that fine?
Okay, ma'am. Okay.
Any other doubt in this question? No? Yeah, such type of question you can assume for your end because it's basic one only. You just have to expand the I mean, you just have to get the idea that what element can be and what element belong to which something. Okay. Right. So now this is the sixth one. Sixth one is a kind of easy, I think, because it's nothing but all x belongs to real number in such a way that x square plus 10 is equals to 0. But we know that if x square plus 10 is equals to 0, so what does it mean? It means x square is equals to minus 10. So that means here we don't have any real, so no real roots. So that's why this set S1 will become empty. Correct? Similarly, for second thing, you can say x square minus 10 is equals to 0. So that means x is equals to plus minus 10 or plus minus root 10. Right? So here you have two elements. And similarly, you can solve this polynomial. I mean, just factor it out and solve its polynomial. You can easily find out what are the elements in S1, S2, S3. Okay. Is that fine?
Yes.
Yes, ma'am.
Yes, ma'am.
Seventh one, in seventh question, you have to find the, first option says find the domain of f of x is equals to 1 by under the root of this thing. So here what happens? So you can use the, yes. Sorry. Okay. So here what happened? We know that if we want to find out the root or the domain of under the root function, then this guy, whatever sitting inside this under the root, should not be a negative one, right? So we want this to be greater than or equal to 0. So here that means we want this guy, this particular denominator one, that minus of x plus 4, x minus 2, x plus 2 and x minus 4 to be greater than or equal to 0. So if you want this to be greater than or equal to 0, if I reverse the minus sign, then we want this quantity to be less than or equal to 0.
Ma'am, it can't be equal to 0 because 1 by 0 is not defined. So less than 0.
Yeah. So that's why this open brackets are there. So yeah, you can take strict inequality also. That means this should be strictly less than 0. Now here it's given that the domain should be this point, that x should be greater than, it should be minus 4 is strictly less than x, strictly less than minus 2, or 2 is less than x is less than 4. Okay, so here observe, if I consider this particular guy, that x is between 2 and 4, and this thing will be positive if I consider any element from this particular interval 2, 4, right? If I consider any x from the interval 2, 4, this guy is positive. This guy will be positive because again it's x minus 2, and whatever quantity is there, it's strictly greater than 2. So that means this is also positive. X plus 2 will be again positive, and this guy will become negative. If I take any number from this particular integral, this will become negative. So that means the whole expression will become negative. So that means our domain can contain this particular interval 2 to 4. Now we talk about the interval minus 4 to minus 2. Okay, so if you consider any x from minus 2 to minus 4, and if you substitute here, so what becomes? So if I want x plus 4 is less than 0, will imply x should be less than minus 4. But here I am taking all x which are greater than minus 4. So that means this will become positive again. And if I want x minus 2 less than 0, I want x less than 2. So here we are taking all x which is less than minus 2. So that means obviously they are less than 2 also. So that means this will become negative. Right. Now again, if I want x plus 2 to be negative, x should be less than minus 2. So here again, we are considering all x less than minus 2. So that's why this also become negative. And if I want x minus 4 to be less than 0, x should be less than 4. So that means this is also become negative. So here we have 3 minus signs. So overall, it will become negative. So that means domain of this function is nothing but this particular interval. Okay, so that means first option is correct. Right? Any doubt in this first option?
No, ma'am.
We are just checking
No,
this.
ma'am. It's clear.
No, ma'am.
Ma'am, what is saddle point, ma'am?
It was clear.
Saddle points are actually those points where your second derivative will become 0 ultimately. So,
Equal to 0.
No local maximum, no local.
No local,
Sorry, ma'am.
a critical point where no maxima or no minimum. So ultimately, you can say that a critical point means your derivative f dash of x should be equals to 0. f double dash of x should be equals to 0, because by second derivative test only we can say that it's, if it is greater than 0, then it will be maxima, less than 0, it will be minima. But if it is neither of them, that means your second derivative should be equals to 0, right? So that means these two conditions should happen if a point is a saddle point. So here f of x is minus of x to the power 100. So yeah, obviously f dash of 0 is 0, f double dash of 0 is also equals to 0. Okay. So using these two conditions, you can take to be a saddle. Okay.
Ma'am, what do you mean by saddle point exactly?
Saddle point, actually those critical points where neither maxima nor minima kind of thing happen. For example, if you consider
if you plot the graph of this minus x is 200, there is a list of points from -1 to 1, which is in a straight line, including 0. Will that all? Yeah, correct.
Yeah, those all won't be a saddle, won't be a
And
saddle.
0 is in the middle, right?
So
0
what?
is in the middle, but
Ma'am,
only 0 is the saddle.
according to ma'am definition of saddle point, it is a point where from one side the
But it
slope
should
is
be a
positive,
critical point.
and on the other side the
It
positive
should
tends to
be-
become negative.
Yeah, but it should be a critical point. So if you consider all the points between -1 to something else, then at this point your derivative is not equals to 0.
So basically, the critical point can only be a saddle point.
A critical
point which
can
is
only
neither
be a
maximum
saddle
nor minimum.
nor minimum is the saddle point.
Ma'am, what is the second option?
Yeah, ma'am. Second
Yeah,
option.
the second option is simply says that if f of x is equals to 8, g of x is equals to 8, then f and g are inverse of themselves. So obviously it's not correct. F of x is a function, a constant function, right? F of x is equals to 8. So this function is not neither injective nor bijective. Neither injective. So it's neither 1, 1 nor on 2, right? So this function is not bijective. So if a function is not bijective, then there is no question of inverse, right? So that means there don't exist any inverse. No inverse. So that's why this option is.
Ma'am, I have a question. Ma'am, as you said the definition of saddle point, that it is not maxima or minima, but ma'am, 0 is maxima for this.
No, 0 is not a maximum. Actually, what happened? It's x to the power 100 now. So as you increase the power, it will become some kind of flat situation here. Because of the power, it will become a saddle point.
But ma'am,
Some kind of flat situation happened there. I mean, around 0, you will have a straight line kind of behavior via this particular graph.
But ma'am, as minus, so ma'am, any positive answer will always be getting negative only, and it is by power and even numbers. So ma'am, it will be always positive, and then minus. So ma'am, it will be always negative. So ma'am, how
So
can
yeah,
it's
I'm
possible?
understanding your point that the graph of this function is just a parabola, just a downward parabola type of thing. But what happens since you are increasing the powers very much, so that's why around 0, it will have a straight line kind of thing. It won't be a saddle, it won't be a critical point because of the power. So here there is one more explanation of this particular question given by the higher order derivative test. So I am not sure you guys are familiar with higher order derivative test.
The answer will be 100 factorial.
Yeah, so there what happened, your highest derivative, whatever you can take, if that will become either greater than 0, less than 0. So using this particular thing, whatever power is there, if there is an even power, then I think that called to be a saddle point or something. So using that description, it's very much clear that why it is a saddle point. But using the graph point of view, I don't think it's that much. But here, because of the power only, you are getting saddle. So I'll give you one option that consider f dash of 0 is equals to 0 and f double dash of 0 is equals to 0. So here these two conditions are happening, right? So using this only, you can say that our second derivative test fails. So at this point, a saddle point could be. So because of these two equations, so you can say that, okay, there is a possibility of saddle. Are you convinced still?
Ma'am, let's say there is another question of similar nature, ma'am. Then how would one should approach solving this problem in a similar
First thing
way?
is,
Take two derivatives and find out. Even x cube is also.
At
yeah, x cube
0.
is also having the saddle point at 0. So that means I'm saying that whenever they ask you about saddle point, just compute these two things. That f dash at that particular point x naught, f double dash at that particular point x. If you get 0, just say that it's a saddle point.
Ma'am, but ma'am, in this question, you have assumed x naught to be 0.
So yeah, because the only saddle point could possible is 0. So I know that f double
by
derivative is
definition
equals to 0 only
of higher
0.
by the definition of higher derivative, this function will not have this saddle point. But right now it is given, so
it
let's.
will have a saddle point. It will have a saddle point. Using higher derivative test, if you apply, so there is one condition over power of derivative. If your power is even,
it states that if it's negative and the concavity is increasing, then there will be a local this minima or like local maxima. But the saddle point will not exist at this point.
Okay, fine. Forget about this moment. Although they won't ask about you anything about
Yeah,
saddle
correct.
point,
This
because
is
we
very
haven't
confusing question. I
Uh-huh.
don't understand why they ask even here.
Because if this mog is not right, I don't know why they give such kind of. I just saw graph theory
Ma'am,
question.
double,
And
ma'am,
for
f
saddle
double dash.
point, the mixed is
Your voice is not clear, Pranod.
ma'am, for saddle point, the mixed second derivative test should be less than or equal to 0, less than 0. Then only it will be.
No.
This
Second
was
derivative is
this is
less than 0.
maxima.
It will be maximum. It should not be less than 0 at all. Okay, so let's go.
Yeah, ma'am.
Forget about saddle point. Assume that you don't know anything about saddle point. That's also fine. No, your score won't affect. Yeah, so fourth option says that if a polynomial this and this have the same remainder divided by x minus 5, then this is happening. So here what you have to use modulus concept, right? So we know that if a number a divide, we know that if a mod x is same as b mod x, then we can simply imply that x divide a minus b, right? Because the remainder obtained from this quantity, E mod x is what? So E mod x actually justify the remainder when we divide A by x, right? And similarly, B mod x means a remainder which will obtain by dividing B via x. If you divide B by x, then whatever remainder is there, that remainder is known to be B mod x, right? And if the two remainders are same, it will simply imply that x divide A minus B. Okay, so you have to use this concept here. So you have two polynomials, px and qx. So here what is happening? X minus 5, if divide px, then the remainder is same. And if x minus 5 divides qx, then the remainder is same. So that means x minus 5 is actually dividing px minus qx. So if you consider the polynomial px minus qx, then x minus 5 will be a one factor of that particular polynomial. So that means x is equals to 5 is a root of px minus qx. Okay, so what does it mean? So it means that p of 5 minus q of 5 is equals to 0. Now you just have to solve this quantity. So if you consider p of 5, if you just subtract these two polynomials, it will become x cube minus x cube will become cancel out, right? So it will be x square plus 2. So that means a minus 2 of x square. 2x minus 3x will become minus x. 5 minus 2a plus 5 minus 2a is equals to 0. Just substitute x is equals to 5 here. So this quantity will become 0. It will nothing but a minus 5 multiplied by 25 is equals to 2a, correct? Means 25a minus 2a and minus 125 is equals to 0. So it will be 23a.
There will be 50, man. This is, I got it. This is a minus 2.
A minus, okay, this is a minus 2. Okay, so this is 50, right? Any other mistake?
No.
So A is equals to some 50 by 23 I'm getting.
Correct.
Here it's not. The value of A is given minus 3 by 2, which is obviously. Okay. Is that fine? Any doubt in this question? This option,
no,
option number 4?
No.
So yeah, this is a valid question. Such kind of thing can be asked
Clear,
in
ma'am.
enter.
Ma'am, if f of g and g of f both are equal, then can we say that the f and g are the inverse?
Sorry, what? Your voice is not that clear. Anyone can explain what you want to say?
Ma'am,
Not
that
audible.
question f of x is equal to 8 and g of x is equal to 8. About
No,
the
no,
inverse.
I am saying that if f of g and g of f are equal, then they are inverse of themselves.
F of x is equals no. At any scenario, these constant function can be inverse of any.
F of g and g of x are equal. Okay, there is a question. If it is written that f of g and g of f are equal, then we
F
can
of
say that they are
g
then g of f.
and no, still you can't say that they are invertible of each other. Inverse of until and unless you find it this to be an identity function, you can't say these two are inverse of each other. So let's go toward the question number 8. Yes. Okay. So what does question number is say? Yeah, I won't suggest you now to focus on mock, because this mock is a little different from end term, whatever given to you. So I'll suggest just solve practice assignment, graded assignment activity. Okay,
Ma'am,
drop
I
it.
don't think so there is any lecture to briefly discuss the modulo.
Modulo. Yeah, this modulo is nothing but, yeah, here
Yeah, I know about
you have to
modulo,
use
but
your
I
intuition.
don't think so that there is any lecture.
I
brief
mean, in the first
discussion.
lecture, we just
Yeah,
introduce
there
what
is
is the
a
modulo.
equivalent relation. That is
Yeah,
defined.
that's all. Okay, so here someone launches the company at year 2010, which makes yearly profit using this particular quadratic function p of x. For 10 years, for first 10 years, since the launch, where x is the number of years since 2010, that dot. Let the loss to be represented by negative profit. Here is one given information that suppose in the year of 2012 and 2014, the company had made neither profit nor loss. So that means if p of x is a function which denotes the profit
Critical point.
profit of this particular thing, then it simply says that p of 2 is equals to p of 4 is equals to 0. Because if the year is 2012, and since we are considering the x to be the number of year after 2010, so for corresponding 2012 we have the value of x to be 2, and for 2014, please mute yourself, we have the value of x to be 4. So that means from this particular given information, I can conclude that p of 2 is equals to p of 4 is equals to 0. So we know that the basic equation for quadratic function is nothing but y is equals to a, x minus the first root, so here in case it's 2, and x minus 4. So this is your p of x function. So where a is undetermined, we don't have any information to determine the value of a. Okay, this is your p of x. So now this is your p of x. We get all the information up to this. Now what does they say? And in the year 2020, in the year 2020, the company has been making profit. Okay, so which of the following options? So that means if you substitute the value of x to be 20, your p of x should be greater than or equal to 0. Correct? So that's why I'll substitute the value 20 years. That means a of 20 minus 2 into, sorry, this should not be 20. We are counting from 2010. So it will be 10, right? 10 years. So that means P of 10 should be greater than or equal to 0. So that means A of 10 minus 2 into 10 plus 4, this should be strictly greater than or equal to 0. That means A multiplied by A multiplied by 14 is greater than or equal to 0. So ultimately your A should be greater than or equal to 0. So that means what is this Px? So this Px is nothing but an upward parabola.
Oh, ma'am, it should be
With the roots, yes.
10 minus 4.
10, yeah, sorry. 10 minus, still it will become the positive one, 6, right? Still our A is greater than or equal to 0. So that means it's an upward parabola. So now using all this information, let's try to counter the options. So first option says that for the given information, the profit made by the company in year 2010 cannot be determined. That's true, because here we have one unknown variable which is known to be A. So in any year, we cannot define what is the profit made by a company. So that's why this option is correct. Now in the first 10 years, the company made a loss in the year 2013 only. Okay. So in the first 10 year, yeah, definitely company made some loss because of this negative portion, but we can't exactly say that the loss the company made a loss in the year 2013 only. Because if you consider any point, if you consider any value of x from the interval 2 to 4, the value of px will become negative. So that means there is a loss at every year. But since we are taking x to be only natural number, we are counting it year by year. So that's why the possible value of x is here 3. So that means p of 3 is less than 0. So yeah, because of that, this option is correct, since we are not taking any real value. So that means the only possible value only possible value between these two interval x belong to 2, 4 is 3. So that means x is equals to 3. So which imply p of 3 is less than 0, and which will imply in 2013 we have a negative profit. Negative profit means loss. So that's why this option is also correct. Is that fine? Any doubt in these two options? Hello?
No, I got it.
Okay. The third option says from the given information, the years for which the company made losses cannot be determined. That's wrong, right? We just determined that in the year 2013 when the company made a loss, right? Now the fourth option says from the given information, the loss made by the company in the year 2013 cannot be determined. Correct. We can't determine the particular value of loss because of this A. This A is unknown to us, so that means we cannot determine what is the quantity, what is the loss made by the company in year 2013. So that's why this option is correct. So any doubt in this particular question? Such type of question won't be there.
Ma'am, from where did you get this question paper? In my question paper, the options are different, little bit. This last D option, the C and D are same.
Oh, okay. Actually, I also have one math 1 idea as you guys have, right? So I just took my mock test. So there, I think there will be one shuffling kind of thing is happening. But although you understand the concept, how you will tackle this particular question, right?
Yeah, ma'am, got it.
Ma'am, I didn't understand that how you made that equation px is equal to a x minus 2 that.
See, it's a quadratic function, right? So any quadratic function can be written in this particular form, intercept form. There are two type of form of parabola, right? One is ax square plus bx plus c, and the another one is ax minus alpha plus into x minus beta, where alpha beta are roots. So I'm using this one.
Yeah, okay.
Okay. Any other doubt? Okay, fine. Now this is the this question is, I think, easy. It's not that tough. You just have to compare two parabolas. This is again a parabola. So many questions based on parabolas. This one.
Yes, ma'am. So the questions are basically from the quadratic equation. Most of the questions.
Only questions are from these also quadratic.
Yeah, 3 questions already, and the maximum weightage is from that calculus part. There is less question in the form 9 to 12.
The first, second, third question also from quadratic only, right? There also we just have to judge a parabola.
There is 3 questions only for quadratic.
Okay, so let's jump to this question number 11. Any doubt in this question?
No, ma'am.
It's a basic right continuity.
No,
you guys are now master in continuity.
Can you explain this once, ma'am, please?
You can consider the left hand limit and right hand limit concept, right? So here I'll just solve one thing. Let's say this one. So limit x going to 2 plus f of x is equals to f of 2. So here we are somehow calculating the right hand limit of f of x at the value 2. So now if I approach the point x is equals to 2 from my right hand side, then function will have the I have to use this this particular expression, right? But since modulus is there and I'm taking all the values which are strictly greater than 2, so that means this modulus will become positive, because what is this? This is x square minus 3x plus
It will
2.
open by positive sign.
X minus 1 into x minus 2. So this is a mod. And since I'm taking all the x strictly greater than 0, so this function will open up with x square minus 3x plus 2 upon x minus 2. And if you solve it, it will become x minus 1 into x minus 2 upon x minus 2. So x minus 2 will get cancelled out and x minus 1 is there. And since I'm x going to 2, so that means x minus 1 reaches to 2 minus 1, which is equals to 1, right? So this is the value of limit x going to 2 plus of f of x. So it's equal to 1. Now we just have to compare with f of 2. So what is f of 2? F of 2 is 1. So that means this is same as f. So this option is correct. Is that fine?
Yes, ma'am.
Okay. Any doubt in this particular? Because such type of question can be there.
Ma'am,
right?
third, like
Last option, ma'am.
f dash of
Ma'am,
3 is
I
equal
say
to
the
F dash 3 is equal to F dash minus 3 equal to 1.
yeah.
This one, f dash of 3.
Second last.
Yes, from second last.
Okay, okay.
Ma'am, why
Yeah,
second
yeah.
option is wrong?
If you consider, because minus sign will be there. I mean, the limit
yeah,
will
it
become
will
minus
open by
1 to
minus
the
Slightly less
mod.
than
that's
2.
why.
X tends to 2 negative, it means slightly less than 2.
You will get minus 1, I think, in that case.
Ma'am, can you have explained continuous?
Now I explained two limits, so you can easily conclude it is continuous or not. So this limit is, this option is not true. So if the left hand limit is not equals to the function
It
value,
is
then
not
obviously it
continuous.
won't be
Not
continuous.
continuous.
Right?
As well as not
Using two options
differentiable.
only.
Yeah, there is a
Yeah,
mod
since
function.
it is
It
not
will form a
differentiable,
sharp corner.
at 2, at x is equals to 2, it is not differentiable, but at x is equals to 3, it can be differentiable, right? So what you have to do, just find out the expression for f of x at x is equals to 3. So that means f of x when x is equals to 3, so that means, I mean, this particular mod will take positive value, because mod of x square minus 3x plus 2, this is same as modulus of x minus 1 into x minus 2. And since I'm considering x to be 3, which is strictly greater than 2, this modulus will become x minus 1 and x minus 2. So that means your function will become x minus 1 into x minus 2 upon x minus 2 around a small neighborhood of x is equals to 3. So that means your function behave like x minus 1 only around x minus 1 only around x is equals to 3. And now if you differentiate it and calculate f dash of 3, so f dash of 3 is nothing but it's a linear function, so it will become 1. Okay, so f dash of 3 is equals to 1. Now same thing we will do for minus 3. So in minus 3 case, what has happened? We are taking x to be minus 3, which is strictly less than 1 and 2. So that means here I am putting some kind of minus 3, I mean a value near to minus 3. Here if you put minus 3, so that means it will become negative and negative, but again negative will become positive. So ultimately the mod function will behave like x minus 1 into x minus 2. Okay, so if you solve this mod around x is equals to minus 3, then it will actually retain its positive side only. So that means f of x is equals to x minus 1 only around x is equals to minus 3. So that's why f dash at minus 3 is also become 1. So that's why I think this option is correct.
Ma'am, for checking the differentiability in that point, you also proceed like the continuity, like it will 2 plus. In the point of x equals to 2, we need to check for 2 plus, limit 2 plus and 2 minus.
Right. For differentiability also we have left hand
Yeah,
derivative,
you need
right hand
to,
derivative also.
then after then we need to first order derivative perform. Then we need to put that value into that.
Right. So whenever mod is there, just a little simplify that particular mod a little bit, then you will get more.
Ma'am, like what if we simplify this modulus function in the initial phase? Like, so I got this 3 functions.
Right. I also try to solve using that. It is something x minus 1 when your x is strictly less than 1. When your x is between 1 and 2, it is something like
I have shared
minus of x minus 1, right?
Yes,
Yeah,
I've
you
shared
can proceed via that also, but I think it will take more time if you use such kind of vital.
Like if we do the second last option by this method, like dividing the function into 3 parts, then the f minus 3 part I was getting the wrong answer actually.
That should not happen because when x is minus, no, here you decompose it into wrong way. Here when x is strictly less than 1, it will behave like x minus 1 only. Sorry, 1 minus x only. Because x is less than 1, x is less than 2. So that minus and minus sign will become positive. You're getting what I want to say? When your x is strictly less than 1, your x minus 1 is also less than 0 and your x minus 2 is also less than 0. So if you multiply it by x minus 1 into x minus 2, then there is no negative sign, there is one, here is one negative sign, so it will become positive. So that means your mod will give us this condition. So that means f of x will be equals to x minus 1 or 1 minus x. Yes, something wrong is happening here. Here, because initially I also did the same thing. I expand all the functions. Yeah, it's x minus 1 only. So yeah, if it is x minus 1, then why you are getting
It's
the
mod
wrong
x minus 1.
mod x minus 1.
Yeah, correct.
But no, not you. Eventually you can say mod x minus 1.
It x equal to minus 3 function is always
It's
positive, so
not,
no need a modulus function.
There should be two conditions for that.
Near x is equals to 3, it's only x minus 1. And near x is equals to minus 3 also, it's behaving like x minus 1. Just expand the mod, you will get your answer. So if these two, function is same, similar kind of behavior happening over 2 points, so that means differentiable and derivative is equals to 1.
Ma'am, can you explain the last option, ma'am? Why f is not differentiable at x is equal to 1?
Yeah, ma'am, same problem.
See, you can see this minus 2 is equals to 1.
Ma'am, can you solve it just once? The last option or the second last?
The second last I already did. No? The
No,
last
last
option
one.
I will solve. So it says that it's differentiable at x is equals to 1 or 1. So again, we just have to consider the left hand derivative, right hand derivative. So see, if I choose x to be less than 1, then what happens? X minus 1 will be less than 0. Right? And since x is less than 1, so if I consider this particular mod, that mod of x square minus 3x plus 2, this is same to be mod of x minus 1, x minus 2, right? So we know that this particular mod will have a little bit, if I draw this particular parabola, x square minus 3x plus 2, then the roots of these parabola is nothing but 1 and 2, right? So this is 1, this is 2. Now, if you draw the parabola, it will be a parabola like this, right? Passing through the roots 1 and 2. And since mod sign is there, it will get reflected here. Now, using the graph, if you see, then you will you'll observe two corner points are there. Right. So this line is not there. So using the graph only, you can say that since there are two corner points at point 1 and at point 2, this function won't be differentiable. At x is equals to 1.
Ma'am, divided by x minus 2 is not taken.
That won't affect at all.
Okay, ma'am.
It's a cusp graph.
Because modulus function is not differentiable. So that's
Yeah, ma'am. Got it, ma'am, your point.
okay. Fine.
Yes, ma'am.
Let's move toward this Riemann sum question. Okay, I'll say that Riemann sum question, this type of tough question won't be there. It is not that tough, but yeah, it's a little bit tough. So here you have to open all the functions. So that's why I'm not explaining these two Riemann sum question, because they won't be there. Sure, this question won't be there.
Okay, ma'am. What, we can give it a try, ma'am. I was waiting for this one.
We can skip, ma'am.
Okay.
But
Actually, I solved this. And
I do have one question on the
Ma'am,
graph.
Ma'am, can you just solve the midpoint?
Ma'am,
only?
very less time is left.
Ma'am,
ma'am.
let's
You
discuss
can
at the
suggest.
last.
I'll just solve this.
Okay.
No,
Let's
I
solve
have
this.
already wait. I have the solution. I'll just provide you the solution. See,
Yeah, ma'am, just
that
provide the
particular
solution.
fx, if you decompose that our fx into modulus and if you open all the mod, you will get this function that x minus 1 when your x is less than equal to 1. You will get minus of x minus 1 when 1 is less than x is less than 2, and you will get x minus 1 when your x is greater than equal to 2. When you decompose that particular graph, this modulus and all those things, if you do little bit changes, you will find out that this is our required. This is our function.
It will be 1 at x equals to 2.
It will be 1 at x is equals to 2. Now
Yeah,
I'm
it is given.
equating this. So at x is equals to 2, it's.
So it will be this upper one is wrong. If x greater than equals to 2, it is wrong. This will be thus x greater than 2.
Why is this so?
X will be strictly greater than 2 for x minus 1. Because at x equals to 2, it is 1.
So if you substitute x is equals to 2 in this expression, what you will get? 2 minus 1 is equals to 1.
Yeah, but we go through the questions there.
Means
Both are same.
Yeah, both are same.
So
both are same, yeah.
At least you heard a
So why I'm doing this? Because we have to use function value at when we want to compute Riemann. That's all.
No, ma'am, I thought that again someone will start that where this one went in the question it was given. So that's why I said.
Okay. So here the first I'll tell that estimated area will be 0 square unit when by taking 3 subinterval of equal. So if I have the interval 0 to 3, what are the 3 subinterval of equal length? Simply 0 to 1, 1 to 2, and 2 to 3. Okay. And the left end point of the subintervals for the height of the rectangle. So whenever we want to find out the Riemann sum. So the Riemann sum is nothing but the function value at some point multiplied by the length of that particular subinterval, and you will sum up over all subintervals. So since here we just have 3 subintervals, and for each subinterval, the length of subintervals are nothing but 1. Right? Because 1 minus 0 is equals to 1, 2 minus 1 is equals to 1. Right? So that's why here Riemann sum will become, and it's clearly mentioned here, we have to consider left end. So that means here left end point is f of 0 multiplied by 1 plus f of 1 multiplied by 1 plus f of 2 multiplied by 1. Now, if you are struggling with function with this particular condition also, suppose we don't require this behavior of function. Forget about it. We just know that the Riemann sum will be equals to something like this expression, f of 0 into 1, f of 1 into 1, f of 2 into 2. Now just substitute the function value, you will get your Riemann sum. So it's nothing but f of 0 plus f of 1 plus f of 2. So if you find out the value of f of 0, so f of 0 will be, just substitute 0 in your function. So it will become 2 upon minus 2, right? So it will be equals to minus 2. So f of 0 is equals to minus 1. And f of 1, if you find out, it will become 0, and f of 2 will become 1, whatever given to us, right? So that means minus 1 and plus 1 will get cancelled out. So our Riemann sum is nothing but 0. So that's why this option is correct, because estimated area will be 0 square unit by taking 3 subintervals. Is that fine?
Man,
Yeah,
Ma'am, can you just give me some hint for solving this graph question? Because from last 1 week I am struggling this clearing this doubt. I have actually posted it. Maybe it's easy, but I don't know. I'm not able to solve this. I just put the question once again in the chat. Screenshot. It looks
This
easy.
graph theory question.
I think we should.
Yes, ma'am.
Forward edge, backward edge. Okay, fine.
Maybe, sir. One. This is last 2 weeks. I am trying to get this answer. Please.
Actually,
just,
it is.
But why don't you ask in the revisions? I mean,
ma'am.
activity practice. Okay, fine. Let's move on.
This concept of forward edge and backward edge is well explained in the TA session. I will provide the link of that session, and you will check that.
Okay. I actually gone through this, but this BD is a forward edge.
Have you watched the
watched
lecture?
all the. I watched
just
all
follow
these,
the given
lectures.
graph from where you draw.
Okay, guys. Yeah, because it's 3:10. I don't have that much time, so let's go through the questions once. Okay, so this question says consider the function with model of this. So it's an easy question. I assuming it's an easy question. Is there any doubt in this question? Continuity, discontinuity, critical point, maximum values, and all those crap is not.
The maximum value of fx.
Ma'am,
See,
actually, the
what you can
maximum
do,
value of fx is coming out to be minus 4 into 4 into 7, that is 28.
yeah, again, it's a quadratic polynomial, right? So you can easily find out what is the graph of this one. So its graph is nothing but it's a parabola. It's an upward parabola with the roots 0 and 3. So 0 and 3 are the roots. So that means it's a parabola with the roots 0 and 3, and it's an upward parabola, right? And we know that the since because of this modulus sign, this particular region will get reflected over the x-axis, and this is the required graph. Right. So this is the required graph. Now using this graph, this yellow one, you can answer all the questions very quickly. So first thing is the number of critical point is 3. So correct. So 1 point is this, second point is this, third point is this. So that the critical points are 3. Right. There will be one point where you will find where your tangent will be parallel to x-axis. Correct. So the number of discontinuity of f of x is 2. That's wrong. It's everywhere continuous. The number of points where f of x is not differentiable, it's 2. Now this is correct because of the modulus behavior. Right? At this point, the function won't be differentiable. At this point, function won't be differentiable. Right? Now x is equals to 0 is a critical point. That's also correct. X is equals to 0 is a critical point. Yeah. The maximum value of f of x is 9/4. This thing you have to compute. Find out the coordinate of vertex. You can answer this by vertex.
But
it will attain minimum value.
1 minute. This maximum is for the entire range, isn't it? Or is it local maximum?
Yes,
Yeah.
ma'am.
If
That was
total,
I'm
if you
saying that
consider
the maximum is coming out to be 28.
That
If
is a
we
minus
take
4.
Yes, ma'am.
28?
Yes, sir.
Since the range
28?
is given and
Yes,
they
yes, for
ask
me
the
also.
local maximum, that's a conceptual difference.
Yeah. If it is a global maximum, then obviously your maximum will attain at 4 and minus 4, right?
Correct.
Endpoints, whatever the endpoints are there.
Since
Because
they
if
ask
this
for
is
a
your
local maximum.
So here I think it's a local maximum
I mean, that is because of the answer.
because of the answer only.
The question
Otherwise,
was
we
not
can't
clear.
say.
The question is not clear. Since a range is given, if I given a minus
Minus
4, they would have said no, the local is different.
Local you have. I mean, yeah, and since it's
I think in future questions it should be more clear. The question should be
correct.
they should
Local
not leave
and
an ambiguity where we have no way of communicating what is our assumption.
Right, correct.
In that one question, ma'am, can you please scroll up, ma'am?
Yes.
Ma'am, if this modulus was not there, then this point would have become the global maximum of this function.
Yeah. Global minimum because it's an
yeah, correct.
Right?
Global minimum. Correct.
This question again won't be there because of the same reason, Riemann sum. Okay. Have anyone tried this question? Actually, I haven't tried.
I did.
So is there any confusion or it's just by
no.
just substituting the function value?
It's very
Ma'am, can you just explain it like just the simple concept?
See, here you have to use this.
I think we should complete the paper and then come back to this because this is
very lengthy question.
Yes, sir.
Because again, it's not worthy to discuss this now, right?
Yes, no, correct.
Day after tomorrow you have exams. Forget about it. Now this relation question is easy, right? I hope so because there is one typo there. Direct flight between city A, city B with fare of rupees C. This question is easy. I mean,
yeah, we can proceed.
And this is the last question. So yesterday we solved the case number 1, and we saw that none of the concept, I mean, neither vertex cover nor independent set is applicable over case number 1. Now let's go to case number 2. So what does case number 2 says? That nodes represent the employees, and if 2 employees share an edge, then they are assigned different centers. So that means if this is one employee and this is another employee, and since they are sharing an edge, so there will be different center for this and different center for this particular one. This guy A and this guy B, right? So the A and B will be given a different center. So it's similar to the coloring thing, right? So we say that 2 vertices will assign different colors if they are adjacent, right? That's the one thing we do in coloring. So that means if you want to answer the case number 2, you just have to find out the minimum number of color for color this graph. And it turns out that there are 3 is the minimum. Why is this so? So if you consider, I'll give yellow color to this one. So then I can't give yellow color to these 3, 4 guys. So I'll give yellow color to this one. Then I can't give it to here. Then yellow here and yellow. Okay. Any other vertex I can't colored using the yellow color, right? This one. Okay. Now if I use red color, so I can color the vertices with red color named this one, and this one. Now still 2 vertices are remained and this one also, right? So I'll choose another color. So let's say it will be blue. So the blue. Okay. So this is the one type of 3 coloring of this particular graph. So that means the minimum number of caps we required in case number 2 is also 3. So that's why this first option, second option is correct. Is that fine?
Ma'am, can you please explain the case number 1? I did not understand yesterday.
Okay, so in case number 1, we just have to use our logic. So what does case number 1 says? So it says that she will arrange the minimum number of cap. That first thing is that each employee is willing to walk at one road length from their current location to a neighbor location to pick up. So that means if I send one cap to this location, the location number L, then if an employee is seated over this location, or this location, he or she is willing to walk up to the location number L. So that means if I send a cap to this particular location number L, then I don't need to send the cap at location these 3 locations, right? So using this logic, I'll try to find out what is the minimum number of cab I require. So one cab I have to send here. So this particular cab, let's name it to be C1. So the cab number C1 will pick up all the people which are lying in these 4 vertices. Now, if I send the second cab over this vertex, then what happens? All the people which are situated over these 4 vertices can be picked up via this cab. This one also. Now only two vertices are remaining. So if I send the cab at this vertex C3, then these 2 vertices are also covered. So that means again I required only 3 cabs to pick all.
3 people
all
can
the
come
employees.
to, right?
Yeah, they are willing to walk one road. So it's their choice if they want to sit into cab number C1 or cab number C3.
So is it because of C3 that we cannot apply the maximum independence set?
See, if you consider the maximum independence set in this graph, then there are 4 elements in maximum independence set. So if you consider this one, and this one, these 3 are independent, and what I can choose another. Yesterday we find out one maximum independence set with 4 vertices. This also not considered.
You have to find the dominant set. Dominant set is the one which has all the neighbors to that.
Yeah, you can go via that. I mean, you can find out an independent set which actually contain 4 elements. Yesterday we find out. Today I don't know.
Ma'am, is case 1 vertex cover basically?
Is it
No,
minimum
case one
vertex
is not a
graph?
vertex cover.
It's
not a
about
vertex.
minimum vertex graph.
No, it's not about minimum vertex.
Case 2 is minimum vertex.
Case 2 is coloring. Case 1 is neither of them. Neither minimum vertex nor independent nor neither of the coloring or anything. Just purely your logic. That's all. Is that fine?
Yes, ma'am.
Yeah, okay. Thank you, ma'am.
Please.
Ma'am, I have a doubt in the previous question. You had discussed that for quadratic equation, global maxima and global minima. How can I say, ma'am, the vertex, there is a maxima here. The vertex of x coordinate of the vertex.
Here it will be local maxima only. So if you consider the graph of this function, it some sort of look like this. Suppose it is a straight line.
Yeah, there is a local max. Yeah.
Here local maxima, not global.
Yeah, but ma'am, in the answer options they say that the maximum
this option
value.
is little bit misleading. They should write either global or local. One of them.
Okay, ma'am.
Okay.
Ma'am, can we solve the
Ma'am, for
question
checking the
without
global
the
maximum and global minimum, we need to check that given interval all the points, like critical and the intervals. Also.
If you want to find global maxima, you also have to consider the endpoints of the domain.
Yeah, with the
Here in this case,
critical
minus
points
4.
that shall belong to that given interval.
Yeah. Okay.
Ma'am, I have a doubt. One question can I ask?
Yeah, please be good.
Ma'am, I want to ask about that unique tangent for x cube. Why the at x equals to or x equals to 0, there is no unique tangent?
Yeah, okay. That question you can check in any one of the revision videos. See what happened at x is equals to 0. If you draw a tangent, it will cut your graph. So a tangent cannot cut your graph. So that's why it's not the unique tangent. Okay. Not there a tangent at all. Yes, Pritham. What? Second last question.
हाँ जी मैम
So the second
समझ में नहीं आ रहा
last
क्वेश्चन क्या
question.
कहना चाह रहे हैं
Okay. So I'll give you a hint. First thing is it's given that f of x has a local maxima at x is equals to 0. So here
Then
it's
second
given
last
that second option.
question number 6 and second last question.
Second last question. The
Yeah, ma'am,
16th
this
one.
question. हाँ जी
It's based on pure relation. You will just try it out. I hope you'll get. Yeah, it's a little bit here. I mean, they say that A, B, C are related if there is a direct flight between A and B and with the cost of C. So that means they are relating three elements together if there is a flight from A and B with the cost C. So if you understand the relation, I think you can easily answer this question.
It can be also solved by using transitive closure, I think.
By?
Transitive. The two paths and one path.
Yeah, okay, you can use any method. This question, forget about it.
Ma'am, I have
Okay.
also doubt an invertible function.
What's your doubt in that?
Like, ma'am, I can say that option that if there is no more question available now left to discuss.
See, 14th question is, 14th question I will give you hint. So first thing you have to use this local maxima condition. So that means f dash at a is equals to 0. So if f dash at a is equals to 0 means the smaller f of a is equals to 0. And this will implies that a can be either 0 or 2 because f of x is equals to x into x minus 2. Now you have to use these two values in place of a and then compute the value of function using this integration. So whatever value you want, suppose you want f of x naught, capital F of x naught. So it's simply 1 to x naught, small f of x dx, small f of dt, right? And use the Riemann sum formula. The Riemann sum formula says that since we have to divide this particular interval into two subintervals. So that means only two subinterval will be there. So -1 with some other point x naught and with some other point x naught and so just find out f of -1 plus f of x. You will get your answer, right? So that's all. That's the only hint I want to give you. Okay. And now this option and this option is a little bit lengthy. You can try it out if you are interested. But for my suggestion is leave this particular question for enter. They won't ask you such complicated Riemann sum question. They can ask you Riemann sum question about like this one, right? It's an easy one. It's not. This is not that tough. But although I'm almost 90% sure that there won't be any question from Riemann sum to calculate Riemann sum. There will be questions from integration, but I don't think they will ask anything from Riemann sum. But
so
still, you have the idea.
Difficulty. So this question's difficulty we can expect in Riemann sums. Okay.
Yeah, this is pretty much standard. If they want to give you, they will give like this or less difficult than this question.
Ma'am, can you answer the last question? That is the 12th question, the option number 3rd and the 4th one, ma'am. They are asking that, no, ma'am, 12th question. The 12th. Yes, ma'am. The third and the 4th option, ma'am. They are asking the midpoint of the subintervals. What is that?
Midpoint of the subinterval. So that means since we are dividing into three subintervals 0, 1, 1, 2, and 2, 3. So what is the midpoint of these intervals? So the midpoint of this interval is 1 plus 0 by 2. That means 1 by 2. For this, it will be 2 plus 1 by 2. That means 3 by 2. And for this, it is 3 plus 2 by 2. That means 5 by 2. So ultimately, an average of these two numbers in that will be your midpoint. So you have to compute function value at these 3 points. And if you
Now
compute,
we
I
have
think
to
the
find
answer
the
is 1 by
function
2.
of this point. Okay, ma'am.
Huh.
Okay.
Ma'am, how
Yeah,
can I
for-
find the function? I don't understand.
How can you find the function? Means function is given to you already. This is function we have to use.
Okay, ma'am.
Yeah. This function only you have to use. In question,
Ma'am, can
they
I
all
tell you now
precisely
the
say, no?
question about the invertible function?
Yeah, let's go.
Ma'am, f of x equals to log mod of x minus 1.
Just a second.
Okay, ma'am.
F of x equals to
Log mod x minus 1.
So what you have to do, you have to find out the inverse of this function.
That's
You
mean,
want to
ma'am,
find out
invertible means the inverse.
Huh. So first thing is this invertible or not? And the second thing
Ma'am,
is,
it is
if
not
yes,
invertible
then what
because
is
there
the
is not one function. So we can't find the inverse function for that.
Is this
Because there
not
is a
one?
mod, I think.
Mod is there. So yeah, it's not
Yeah.
one. So they
It's
have
for
given you
horizontal
it's not invertible.
line test.
Huh.
Ma'am, one
So they
that is
have
the
something
question. It
like
is g of x equals to log of x cube.
G of x is equals to
Log of x cube. And domain
so-
of f dot g f of g of x.
Yeah. So you have to find, I think I already discussed this question. I'm remembering something like this. So you have to find out domain of composite G, that's all, right?
Yeah, ma'am.
So here, whenever you want to find out domain of F composite G, just consider the domain of G and remove all those points from domain of F in such a way that
Okay. That's
G
mean,
of
ma'am,
X does not
g
belong.
of x need to be g of x range need to be subset of that f of x. F of x domain.
So, some kind of that you can assume.
Yeah, then the g of x domain become that f of g domain. Otherwise, you need to minus that point from the g of x.
So now this question, this forward edge, backward edge. This is the last question I am considering.
Please, ma'am, please. Because this is the question, the graph is already given. I try to solve this by creating this DFS.
Okay. So
And then
DFS.
so that A, B, C, E, F as per the alphabetical order, that word is something maybe it's different. I don't know why this word is important. So I did it.
Okay.
My question was why BD is not a forward edge. Lots of people give the
Why
answer,
BD
but
is-
still the doubt is not.
BD is not a forward.
Cross
See,
edge.
forward edges and backward edges and all those edges are those edges which are not present in tree. Not present in tree. So here the BD edge is actually present in your tree. So that means it can't be either of them, not forward, not backward, not cross, nothing else. So forward,
AC
backward,
is also present.
cross this.
Oh, sorry.
AC is not present. Na? AC will come something like this. So that means it's a forward edge.
Okay, so whatever is present in actual tree, and that should, if it is also present in this graph, then it's not a forward edge.
Any kind of edge. Not forward, not backward, nothing. So we consider all those edges which are not the part of our DFS tree.
Ma'am, because there is a pre and a post numbering calculation to find this forward and backward. So if I just do the same for this graph, then it's showing that BD is also
your
forward
edge. But it's actually included in tree. That's why you have to exclude it.
Okay.
So the forward, I mean, this definition starts with the thing that if an edge which is not present in tree is called to be forward and backward and so forth. Okay, so first condition is yes.
Ma'am, to find the non-tree edges like the forward, backward edges, and to do this pre and post numbering, we'll do that on the DFS tree or we'll do that on the graph itself?
You will do that into your DFS tree. On graph, we won't provide any kind of number. DFS numbering will be given onto your. Okay.
Okay.
So.
Thank you.
Okay.
May I send a
Okay,
question? Please explain it. Limit and tends to infinite.
This one,
Thank you,
an
ma'am.
is equals to 1 by 10 plus minus 1 to the power n upon n cube.
Yes, ma'am.
So I'll suggest you just try it out by yourself. I mean, at this time, you should answer this particular
Ma'am, I
question
try,
by
ma'am,
yourself.
but answer is not match.
So that means answer is wrong. What's your answer?
0.1.
What is the limit? 0.1. So correct. Yeah,
But
so
ma'am,
that means the
answer is
given
given-
answer is wrong.
But ma'am, answer is given 0.08 or 0.12. This is PYQ question.
They have given the range. They have given the range, I think. They haven't given you the exact answer. They have given the range from 0.8 to 1.2. Any number could be your answer. So you obviously, this is a very good, basic question. As n goes to infinity, 1 by n tends to 0. So minus 1 to the power n upon n cube also tends to 0. So that means the answer is 1 by 10, which is 0.2. So you're right.
Wait
Okay.
for I will send a full question.
Okay, fine then. That's all from my side. Any particular doubt you want to ask? Anything you want to ask related to exam, you can ask now. I'll be here for 10 minutes.
I send my question. I send.
Array, they have given the possible range 0.08 to 0.12. So if you type any number, if you type 0.9, then also you will get the correct answer. If you type 1.1, then also they will say that your answer is correct. Here they have given the range, not the exact answer. Okay.
Okay. Yeah.
Anything else?
Ma'am, in exam,
Saddle point, forget about saddle points. Yes.
Ma'am, in paper, question will be more from calculus because 30% is from graph theory and rest 70%.
No, see, paper, what can I say about this? I mean, yeah, some 1 or 2 questions from limit, continuity, differentiability will be there. 4 to 5 questions from graph theory will be there. And obviously quadratic function, domain of function. So one questions you can assume from each topic.
One question.
Huh.
Okay.
Okay.
Ma'am, in that
Just
12th
don't
question,
worry that. Yes, Vishnu, what?
in that 12th question, can you solve that middle point Riemann sum? I'm not getting the answer correct. I applied it, but still I'm getting the answer as 1.5, not that answer.
1.5 is the answer for middle point.
Oh,
Yeah,
5
not
point,
1.5,
5 by 2 is
0.5 is the answer.
oh, yes,
0.5 is.
Oh,
So if you calculate the values now, so the, I mean, the value, I mean, f of 1 by 2 will become 1 by 2 minus 1, and f of 3 by 2 will become 3 by 2 minus 1, and f of 5 by 2 will become 5 by 2 minus 1. If you solve this, you will get 1 by 2.
okay, ma'am, I'll try it.
You may have done.
Ma'am, what are strongly connected components, SCCs?
Strongly connected component. Actually, I don't know the particular definition of strongly connected. I know
If
the
there is an
connected
edge from I
components.
to J and J to I, I mean the path, there is a path.
Okay. There is a path from J to I, then I to, so it will be defined in directed graph, right? Because in undirected graph, it doesn't make sense. So in directed graph, I think they use strongly connected.
Okay, ma'am.
How many questions will be there in total?
15 to 16, you can assume.
15. Okay.
Have you guys seen the last term question paper or last term?
Yes,
question
ma'am.
paper?
Yes, ma'am.
Yeah.
So you can assume the same pattern. Whatever pattern will be followed there, same type of pattern will be here also.
Those theoretical questions are way more different than these mocks questions. Better to solve those PYQs instead of.
Your voice is not clear, Praveen.
I was saying that the mock questions are way more. PYQ questions
mock
are way
questions
more
are
different
way
than
more different from the end term question. I mean, especially the calculus part. The graph theory part is easy since there are only 2 questions, but still it's comparatively easy. But the other calculus question, they are little bit tough. Okay. So I think with this I can wind it up. All the best for your end term. Just revise whatever you learn and
Thank you.
Thank you, ma'am.
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 Okay.
Ma'am.
Bye bye.
Thank you,
This
ma'am.
is the last session.
Bye, ma'am.
Bye, ma'am.